I found out I was going to give this morning. So luckily, I had some slides that I was working on anyway. So I work on an open source project called Dat, and I just wanted to kind of share our use case. I am really excited we get to use Node for something other than building websites, and I think it's a really fun project that I am excited to have a budget to work on also, and it's open source. So I kind of just want to share with you and tell you what we're doing. And this is kind of the state of the project as of this part of 2014. I'm Max, and I organize a project called Node School, and I just want to do a shout out about Node School. We came up with the idea of chapters a few months ago. We have 60 chapters around the world now in like 3 months, and I think that makes us the largest Node community. So if you haven't got involved in Node School, I'm going to guilt trip you right here. I'm looking at every one of you in the eyes. Either join your Node School, find the chapter, or if you know another language, translate the web page or translate a workshop and help it spread even more globally. Starting a chapter, you just go to the website and follow the guide, and it's really easy. And if there's already a chapter, you can just join it. I also really love cats. So Dat and cat, they have 2 out of 3 of the same letters by design. Dat is for sharing data and also collaborating on data. There's 2 phases to it. It's about a year old, and we are grant funded. We're not a startup. A lot of people think we're a startup because we have a logo. We're just a grant funded project. And basically in the US, there's all these dead rich people that when they die, they give all their money to a trust or a foundation. And then they spend the money, and the money lasts a long time because people get really rich here. So we've been funded by like newspaper empires, by automotive empires, exploitative industries in the past that are now trying to offset their, anyway. So that's how we make money, if anybody was wondering. Well, we're 100% open source, and we have a distributed team. We're working on some really cool stuff. And we've been writing a lot of documentation about kind of how we're doing the project, from things like, I have a repo that's just like how our team is trying to work as a remote async team. We also have been writing a ton of modules. Like I think just between me and Matthias, we have like 500 modules. And so we took the time to kind of like write down how we built the thing. So you can go to our docs on that and read those. The main goal of the project, the current funder came to us and said, we see that you're doing stuff with data. I had come from a open government background. They said, we're seeing you're doing stuff with data. Have you considered working with scientists? Because there's this movement called reproducible science. And we want you to work on that. If we don't pay you to work on that, you're going to go work on something else. So we want you to work on this. And I was like, that sounds awesome. I love science. I'm not a scientist. But they're like, that's cool. Scientists need better data tools and better reproducibility tools. And it reminds me a lot, basically, of like Travis CI, but for science or something like that. Maybe that's a bad metaphor, but the idea is if you're a scientist, you publish a paper. How did you build the paper? You wrote some code that generated some LaTeX, or maybe you generated some graphs based on some R code or some Python code, and you had to feed some data into those pieces of code, and you had to scrape the data from FTP servers. There's just like this incredible stack of dependencies, and if any other scientist gets it running, it's a miracle. That's the state of science today, and there's no incentive to do it. You get tenure by writing papers. You don't get tenure by writing test cases for your unit tests for your science code. So there's a lot of people with a lot of money trying to fix this problem and make science something where 2 scientists can actually reproduce each other's results. Because a lot of people think if it's not science until 2 people can independently verify. Otherwise, it's just you're trusting someone's things that they wrote down in a paper. So what our project is about is kind of like Git, but for data. So source control. Before Git, you had, did anybody do code before Git or like maybe even before Subversion? It's, man, we used to do that. Remember, there were like, 40, 50 years of computing pre-source control. People did it. And, if you had a cool project, you want to fix a bug, how did you find it? You got a zip file or something. You unpacked it, and you manually edited it in notepad.exe or whatever, and you would email the file back to the maintainer, and maybe you never heard back. It's like a black hole. And like number 4 is actually the most important one. Like nobody knows what happens after you email back. Usually the maintainer would like maybe copy paste your code in and make a new zip and just hope the new zip finds the users. And it's totally just like the most insane. There's just like no rhyme or reason. And then Git came along, and Git added all these cool verbs that tracked changes, and you could actually diff and stuff like that. But you still had to email. That was kind of annoying, emailing patch files. But hey, it was better than nothing. And then GitHub came along because of Git like a few years later, and you didn't have to email anymore. And this is actually, from a collaboration standpoint, email inboxes aren't public, so it's really important that if you're about to send a pull request, you can be like, wait, I should check if there's somebody else that's already sent this pull request. That's what GitHub does, among other things, emoji. So with Git, you don't have to do all those manual steps. You can just git pull. So our claim, our kind of operating premise of the project is that data sharing, anybody that's worked with data knows it's the same thing as the zip file source control thing. It's like you find an FTP server, you download a CSV, you have to parse the CSV into your database. You end up writing like a stack of code that only does one thing, and it's super like monolithic and brittle. And if 6 months later you want to switch to a different database, you have to rewrite all your code. Or if you want to download the CSV again, you have to like delete all of the data you imported last time and then just re-import the whole thing again. Or it's just like there's no automation. And if there's no automation, there's no reproducibility for these scientists. So you have to do things like emailing CSV files around now. This is a popular one. If it fits in Git, you can just put your SQLite table or export into Git, which is just like a crazy hack. And so we're just trying to do for data what Git did for source code. And don't take that too literally. Some people think we literally have the same commands as Git, but it's a different problem, so we have a different approach. But we're inspired by the automation that Git brings. So dat is a module. You can install dat, and we have a lot of dependencies. The only dependencies that aren't JavaScript are Node itself and LevelDB. And there's a command line API. So the main idea with dat is you can do dat init, create a new dat store in a folder. Anything that produces data, you can pipe into a dat import, and then that starts tracking the data in dat. And then once it's in dat, you can do things like dat listen, which starts a server that other people can dat pull from, or dat clone. You can dat push to another server. We're just trying to make these automated data sharing pipelines easy and on the command line. I always forget that I highlight those. So for instance, let me just show a demo. I have my 23andMe data somewhere in one of these. So I have in the command line, this is just like an empty folder. There's nothing in here, nothing up my sleeve. And if I do dat init and make a new dat folder, it kind of asks me for some metadata. I'll say my genetic markers from 23andMe. And I guess I am my own publisher of my DNA. And so if I run this little pipeline, the data comes from 23andMe as a TSV, and so it kind of looks like this. It's basically a CSV, but these are tabs. And I can parse it using this CSV parser module that we wrote with a tab separator. So if I basically just run this little pipeline here, then the last one is dat import. So I'll run that, and it'll just sit there and start importing parsing the TSV and importing it into dat. And now I have, I don't actually know how much data is in this thing. I think it's like 80,000 base pairs or something like that. But this might take a little while because genomes are big, so I'll just kill it. And I'll say dat listen, and I can open up the server, and we have a little admin UI. And now it'll kind of, I think the first time it has to do some indexing. Let me do a dat cat. Oh yeah, here we go. So there's I just imported 91,000 rows of my data into dat, and what it adds is the version. So if I go in, say I'm a genetic mutation, and I say this is now a CC, and I update, then now there's version 2 of this row. And that means that also if I go into, to the changes feed, kind of like CouchDB style, and I get the last one, then the last change to my genome was this key changed from 1 to 2. And we track this kind of metadata. And the metadata we use to do replication. And that means, and we're also building kind of branching and merging, and so you can kind of do pull requests on data, and everything is streaming. So the whole idea with this is you can track changes to data, have versions of data, push and pull data between remotes, and then we're building a lot of cool plugins on top of it. And so you can clone a data set from a server, and then once you have a data set, you just do dat pull, and then you get the newest version. You can do dat pull live, and this is where we start diverging from Git. With Git, you can pull like discretely, but with that, you can be continuously pulling because it's just a database. So you can have the data be like live updating, like Dropbox. And we don't just do tabular data, we also do large attachments. We call them blobs, binary large objects. And there's a blob API for storing blobs. The blobs are not stored in the database, they're stored on the file system. But we store all the actual data, like the key value data, in LevelDB, because it's good at that. We store blobs on file systems, because file systems are good at files. But we've abstracted the file system using this module called the abstract blob store. And this is like a community thing that we're trying to get going, which is, say you want to upload files anywhere. Don't write code that uploads to S3 directly. Write a S3 blob store, or actually it turns out that we've already written one that you can use for S3. But if it's basically an API where you're streaming in and streaming out and it's files, that's what the abstract blob store is meant for. But what's cool is you can use our test suite, and then you're compatible with all the other blob stores. So your uploader service can instantly be compatible with all the blob stores that we support or that are implemented by different people. So we're just trying to introduce nice little conventions so that we can not reinvent the wheel every time we want to do file upload. Oh, yeah, we also have cool ones like you can read a file from BitTorrent using the same API as you use to read a file from S3. Or do FTP or local FS or in-memory. So check out the abstract blob store module. And then we also do some stuff just really quickly with that. When you import data, we generate you a JSON schema by default, but you can go in and we actually use protocol buffers from Google to do the actual encoding. So if you have a specific schema you want, you can do your own schema. We give you a free REST API on top of the database. I kind of showed you the changes feed really quickly. And everything in DAT is totally 100% streaming, so we can work with really large data sets without crashing DAT. So some demos. So NPM is a cool data set. We actually have been importing the NPM metadata into DAT, so we have up online npm.dathub.org. Dathub.org isn't a real thing. It's just where we host little DATs right now. So we have 117,000 modules. It's more than NPM because we store the deleted ones also. And we store the full data. So NPM actually has like a lot of data. Every version of every module is in every row. So, and then we have the readmes. So if I take this URL and I go to the terminal and do I already have one here? Okay, cool. So if I dat clone this, what it'll do is start cloning it. And what it looks for is the blobs. Oh yeah, so we actually store links to the tarballs. And by default, when you clone, dat will clone the tarballs, so you'll have them locally. So as you get a row, it also fetches the blobs. So you're actually, I mean, this will be 140 gigs. It'll eventually finish, and you can make a full copy of NPM. And if you have a lot of bandwidth, it doesn't, I mean, it's doable. But it's a little bit much for conference talks. So let me start over. I'll delete the folder, and this time I'll do --skim. And what this means, skim mode, is we just skip the blobs. We just stream the tarballs. So then it only takes about 10 minutes to clone all of NPM, just the metadata, including all the readmes. And so then you can actually run your own little local registry, and when you actually want to get a tarball, it just lazily fetches it. Because we still have a link to the tarball, and to dat, it's just a matter of has it fetched it and cached it yet or not. So, and you can stop it and then go back into there and do a dat pull, and it'll finish where it left off, and then you can do pull -- live, and it'll keep in sync. Just like a cooking show, I have the full version already done. And if I go to, where's my slides? Did that one? So we have a little demo where we can calculate how big NPM is. All we do is loop over every row using the dat JavaScript API. And we just have a rolling sum of all the blobs. How many tarballs are in NPM, basically? So if I run this size of NPM, it basically just streams through dat and just calculates a big rolling sum of accumulated tarball size, and I think it's around 150 gigs or something right now. But it takes a minute to run. And so that's an example of like streaming data out of DAT, but we also have doing something a little bit more cool. You can pipe datcat, which is just all the data in DAT, out into some transform, anything Unix. We're super Unix fans. And you can also, since Docker is Unixy, you can do really cool stuff with Docker. So you can, this is kind of like a really important use case in science because dependencies are hard. So we've been using Docker for a lot of these crazy science dependencies. So this is an example. If I wanted to generate a screenshot of every README on NPM as a stream, we wrote or Matthias wrote this cool thing called bulk-markdown-to-png. And I can just run that really quick. So we have this little pipeline that gets all the modules greater than or equal to DAT, so like the DAT module, and then pipes them into Matthias's thing, and that generates a tarball. So let me actually grab this, and I'll not do 1, I'll do like 10 actually. So, oops. The emoji cat in my PS1 kind of messes with stuff sometimes. Oh yeah, greater than DAT, limit 10. So I'll generate 10 readmes. Like the first 10 modules that have DAT in the name on NPM. So what it's doing is it's piping data out of DAT, spawning a little virtual Linux container using Docker, generating a README in a headless browser, and then it generated me this tarball just now. And if I extract the tarball, then I get a folder full of PNGs, and they're basically rendered in Phantom.js. But you don't have to worry about that. You just use the Docker container, and everything's streaming. So you can do like these really nice advanced data processing things on data sets of infinite size with like relative ease. That's kind of the goal. And we also made this, which we're really proud of, which is called, where is it? Here, I'll just go to it directly. It's called getDat. We also use Docker for this. It's an in-browser DAT environment. We log you in as root to a new Linux machine on our server. It's a virtual machine. And who am I? I am root. Your sandbox though, and you can type stuff like npm install the unique module from npm, and it'll actually get a real npm. It'll do a real npm install on the file system. But in order to make it a little bit easier to learn, we sync the file system to this little editor that we wrote. So you can actually go in there and inspect it, and you can say, oh, I want to go edit the source code of this module, and say console log hello JSFest. And then if you go up here and you go into the node REPL and require unique, then it'll type hello JSFest. So we sync the file system back and forth from the browser to the server. So the point of this is you have this tutorial over here that teaches you the fundamentals of DAT. You can also do stuff like require an HTTP server and live coding with latency. So if I write a little HTTP server in here, we wanted it to be real. So it's like you could actually do real stuff on a real server and not do like a fake environment like what like Codecademy does or something like that. So if I just say res end hi, then I go to my welcome text. It has when you load the page, it gives you a unique host. And anything that listens on port 80 is a real server on the real internet. So I have hi here. So what's cool is when you close the tab, we close the process. So you can't, it's kind of like our anti-abuse policy. So now I can't find it. But we do store the data. So in the tutorial, you actually use a real DAT, you start a real DAT server, and you actually clone your own data from the server down to your laptop. So you install that locally on like step 5. So we wanted to do something real. And this is actually a preview of, we're working on adding this functionality to all Node schools so that anyone can get Node school in one click and not have to install everything locally if they don't want to. We're also working on a bunch of DNA processing. One of the people on our team is doing his PhD on this stuff, and we have a project called bionode. And what that has taught us is that we need to handle these advanced data pipelines with lots of crazy dependencies, and everything needs to be streaming because the data sets are huge. And we're using a lot of Docker for automating these really difficult to install bioinformatics tools. We've been playing around with this thing called gasket. If you were at NodeConf this summer, we had a very early version of that, which is like trying to build these cross-platform data pipelines where basically it's a really cool use case for Node, I think, because Node isn't doing the computation. Node is spawning the processes and moving the data between them. So it's just, that's kind of, it's I/O. Literally, it's what Node is built for. And not everything is one monolithic Node app. It's an evented pipeline where data is getting piped in and out of different places and coming from different network services. So I think it's a really cool use case. And Gasket looks like this. It's JSON, and you can declare pipelines. But it's a little bit too linear for us, so we've been experimenting with this thing called datscript, super experimental, which you can define pipelines that do stuff like, this is a reads pipeline. It will run a search that outputs JSON, and then fork 4 pipelines and pipe the search output into all 4, and then aggregate those 4 pipelines into a DAT. So you can do really powerful stuff in a really simple expressive syntax. This is like super alpha, but this is the kind of stuff that we're interested in. Stuff that's the future of the project. We want to be able to check out a data set to a specific point in time, just like Git. So you can say, get me the data as it was 2 weeks ago, so that when you publish your paper, you can have the hash of the data of the paper so people can reproduce it. We're doing a lot of really cool stuff for multi-master replication and merging that Matthias will talk about. And we want to sync to a bunch of different databases so that you can have stuff like, I wrote a thing the other day that takes any data from DAT and puts it into a full text index. So you can just do that automatically and not have to install a database. It uses SQLite under the hood, but we can swap it out for like Elasticsearch. Doing these like data automation tasks. And then finally, we're building a registry, which is like what I'm super excited about. The registry, this is like a super sneak preview. First time we've shown it publicly at all. It's not even like alpha yet. We're still working on the first version, but you'll be able to publish data sets to the registry and find them and clone them and get information about them and actually view the data in line. And this is super, super early, like I said, but we think that putting all the data online and making it easy to find is going to help a lot of build these ecosystems out. So with that, this is like how to find us, Dat on Freenode, where we have a getter, and we're also the Dat repo. And I'll hand it off to Matthias now. So thank you.